Okay, my name's John Wood, but before I begin, I'm just going to say a little thing about OWASP, especially to the new people who came here. My first ever OWASP event was actually in a pub about 200 meters away from here, I would say 18 or 19 years ago. And at the time, we were meeting in a pub and, well, there's probably 10 or 12 people there. And there's a certain individual there who's here tonight, and it's Dennis Cruz. So if Dennis can actually just quickly stand up, because I want to embarrass him wonderfully. So Dennis has been at the heart of London OWASP for 20 years?
20 years exactly.
20 years. And he has spent so much time at OWASP, and it's been a huge commitment educating the wider world about AppSec. And I think what I'd really like to do, Dennis, I recognize that, so I want to give you a big round of applause for that. Because the interesting thing with where OWASP goes, so I started attending London OWASP meetings. I then found myself up in Scotland, so I set up the Scottish OWASP group and kickstarted that. And then last year, Aurelien and I were in Barcelona doing another one of these types of talks. You will learn so much about application security through OWASP, and an awful lot more than you probably will in your corporate lives. It's the communication and the talks which you really gain all of that experience here. So anyway, Dennis, thank you very much, and that's sort of on that part. Okay, on with the presentation, or the talk, whatever we're doing tonight. Okay. I'm going to observe an awful lot of the OWASP rules, so this is non-corporate. And I've been in application security since 2005, 2006. I worked for an organization called Fortify Software. So first of all, I now have to apologize for the false positives. It really wasn't meant to be that way. Terribly sorry. But I've seen this industry evolve and all the big changes in it, from static analysis, dynamic analysis, through to maturity models and SCA. And I left the industry about 2 or 3 years ago, kind of just had enough. Couldn't see a way forward. And then I started thinking about, well, what is the next big change happening in application security? Because we haven't solved the problem. And the simple fact is that first age of the technologies which we developed in the early 2000s, the big static analyzers, the SCA, whatever it might be, that's all come to an end. And we need to change because the challenge we're now facing is unprecedented. When we started OWASP, you would have one major release a year and 2 dot releases. We're now on hourly, minute, by second releases. So the tools and techniques we used to use are simply ill-suited for that particular future. And what we've been doing, we've been thinking about how we actually change this. How do we actually reimagine the world of application security and break free of those particular shackles? And that's some of the stuff we're going to be talking about today. And we're going to do it in a slightly different way. You don't often see pictures of Africa at OWASP meetings. And what I want to do is just really emphasize what's been happening in the industry. This is an image of an African desk. And I was in Africa about 25 years ago, sleeping in a really cheap 2-man tent in the middle of a game park, because that's the type of thing you do. Slept all the way through the night, not a problem. Woke up in the morning, unzipped the tent, looked up, great African sky, looked down and went, oh crikey. And what was in front of me was a paw print about that big. Basically, a male lion had come into the camp, had a good look around, sniffed outside the tent door, and then gone. And that's what we're doing in application security. We don't know the threats which are actually out there. I was lucky that night, as simple as that. It could have all gone south very, very quickly. And it's the same in our world. There are so many threats out there we're not seeing, and we don't know when we're going to be attacked. We've got to start changing that. We've got to turn that on its head. And one of the biggest problems we have in application security at the moment is that we have too much noise. All the technology is just, crikey, how many more vulnerability reports do we need? How many more CVs do we need? I read something yesterday saying, oh, we now need yet another dashboard. Well, of course we do. And that can then add to the next 10 dashboards we're already not really doing anything about. So we've got to change this around. We've got to look at this noise and go, that doesn't work anymore. How do we actually get the clarity and actually start acting on the signals we're actually seeing? And I would suggest the biggest problem is this problem of context. It's not a technology problem. It's not a human behavioral problem. It's context. And what we need to start doing is looking at how we deliver information which is accurate, relevant, that's a big one, and also is crystal clear. That's the challenge we're facing. And to sort of highlight that challenge, I'm going to introduce you to Big Boy. This is actually on the same day after this is the same day as the lion paw print. It was a hell of a day in Africa. So I'm actually walking through the bush with my guide and another local guide. Just as you do, average day, walking up a hill, and we come across this guy, Big Boy. That is a teenage hormonal male elephant who's only got two things on his mind. One is, are you going to become his special friend, or is he going to kill you? It's pretty binary. Oh, and he might want to eat some food. We're in the wrong place at the wrong time, and we've got a curious, aggressive elephant. And what this elephant does, he goes back into the bush, has a bit of a shuffle around, comes out, and does a fake charge. Not a problem. My guide, Anne-Marie, this is her here, literally is going, shoo, go away. I'm 3 meters away going, it's not a bloody dog. It's an elephant. But then the elephant literally goes, well, okay, turns around, goes back into the bush. Okay. 30 seconds later, elephant reappears. This time, it's a more substantial charge. And Anne-Marie is now up in front. Get away, Big Boy. She's put down her weapon because the idea is not to shoot elephants. And he goes back again. I'm thinking, great. But I notice that Anne-Marie, she picks up her weapon, just starts moving back slowly. I think, oh, something's going on. Because then Bad Boy reappears, and there's two sounds I'll never forget. One is when an African elephant bellows before a charge. It is very, very loud and scary. The second sound is when those ears crack back, because that's when the charge is about to happen. What happens then is this information in context. The first piece of information I receive is fantastic. Run. No debate here. Turned around, and I'm running. Next thing I hear is Anne-Marie. This is being live streamed, so we'll do the Disney version, not the version where John swears like a pirate. Is Anne-Marie goes, no, not that way, run down the hill. To which I literally stopped and went, why? God knows why I did it, but that's what I did. And she just looked at me as she was running past with an elephant, no, probably about 10 meters away, and she gave me the perfect piece of advice. Run down the hill because elephants can't run down hills. I was down that hill in a millisecond. Bad Boy carried on, we all got to live. That phrase, elephants can't run downhill, is my favorite sentence in the entire English language, because that probably saved my life. But more importantly, it was perfect information in context. It was absolutely relevant. So when you do the work I was doing over there, you go attend a lot of seminars beforehand, and they will give you in nauseating detail via PowerPoint all the things you're meant to do when you're out in the bush. Nobody ever pays any attention to a PowerPoint. But what Anne-Marie did was she gave me highly accurate information, which was highly relevant and delivered very, very clearly, upon which I acted. And that is what I mean about context. But this is what we don't do in application security. We kind of just vomit results back at people and say, good luck, hope it goes well. And this is how we've got to actually start changing things. And the reason why we've got to start changing it, and this actually really annoys me. I don't know if there's any other vendors here. And by the way, Contrast does this, every other vendor. But I picked up 5 of these reports, and they're published every year. It's the State of Software Security report, or the State of API Security, or the State of SCA. And they're depressing. They're not really pieces of research. They're just more how bad everything is. And it's the typical 290 days to fix a vulnerability. Only 40% of critical vulnerabilities are fixed. My favorite one is from Black Duck, which says only 5% of applications have no vulnerabilities, to which any developer goes, yeah, but anybody can write 3 lines of code, which is fairly decent. So it's all out of particular scope and scale here. And the thing which really annoys me more about this is that every year it doesn't improve. Or if it does, it's by 0.01%. Remediation is less than 3%. And as AppSec professionals, you're seeing this every day in your life, in your daily lives, and yet you're being told more and more this is the big problem. And so what we need to do, and the other thing with these reports, which I really don't understand, is that when I look at that and I put on my different head and I start beginning to think like a cyber criminal, you've actually just delivered the playbook to those people. You're now actually saying, or we as an industry are saying, you have 290 days before anything will happen, give or take. And as a hacker, that's not bad. You're also going to tell me there's pretty much a 50-50 chance that vulnerability may or may not be ever fixed. I like these odds. You're giving me all the reasons, and some of the reports actually go into the detail of the types of attacks which are successful, which is even more insane, of going, well, if you use this particular TTP, that's, we've noticed a big rise in attacks and it's led to ABC. You're going, why would we give the playbook to the cyber criminals? And why are we not improving? And instead, what we need to do, like any good sort of innovation, we've got to flip the model on its head. What we're doing at the moment in terms of static scanning, dynamic scanning, all of those tools, they're all great and they all, quite frankly, work really, really well, probably a little bit too well. And we started asking ourselves a different type of question. And that was, why are we scanning from the outside? Why don't we actually start listening from the inside of the application? Imagining actually how and seeing attacks coming in at the code level from inside the application. Even more importantly, tell when the application's under attack, because we're not under attack constantly. Some applications are attacked more than others. Tier 2 and Tier 3 applications are a particular sweet spot at the moment. So this is how we started thinking about it. And we started thinking about runtime technologies and how you can actually start flipping those terrible results we've had for 20 years where we haven't really moved the needle into something a lot more dynamic. And this is the point when Aurelien is now going to go into some more technical detail. Okay, Aurelien, after you.
Yes, hello, thank you everyone. So just a quick introduction about me. So I'm Aurelien Svevi, I'm solution engineer at Contrast. So 90% of my job is making sure that John is not saying wrong thing about what we do. So you've probably all heard about the analogy of application security, comparing that to an house where you have a door, you have locks, you have windows, and all of those things are a different product. But I think your application layer is way more complicated than an actual house. It's more like an actual city with hundreds or thousands of applications communicating together with different links, and this is constantly changing. And you won't protect your city with just putting a door in front. And basically, your application layer is maybe even more complicated than a city. But we try to secure that with traditional technology, SAST, SAST, SCA, and WAF. But those tools are not looking at the application itself. Those tools are looking just a part of each of this application. You will look at the code, you will look at the library, you will look at the HTTP request, but all of that with different product and separately. We don't look at the application, we look at the ingredients. And you know what? You can have very good ingredients and that will do garbage food. I'm not saying that because I'm French and I will have dinner in London tonight, but I have experience with that. And so again, all of those tools are missing some context. And if we want to detect properly vulnerabilities in application, we need some context. So, but how can we do that? And there is clues that exist, and you all know them. And when I will mention that, you will only see that now, and you will always remember those two things. All the other layer of your environment has made a huge shift from scanning to actually behavior analysis. We had this discussion 10 years back about EDR. You had this discussion with your colleague saying, well, I have this antivirus, but I know this pretty weird technology, which is called EDR, doing some weird thing on my laptop. I will never install that. Do you imagine now not having EDR on your application? You won't. And that's exactly the same shit. You are doing a behavior analysis. And also, EDR is just an example. You have all the DR that could exist in your environment. And when you speak with AppSec people, they will all tell you that they want those contexts. They want to know which vulnerability is actually exploited. They want to get all of those contexts of what is the potential impact of these vulnerabilities. I have 10,000 vulnerabilities, but which one is actually the one that will kill my application? And the answer is in production. All of those information are actually in production. Because in production, that's where you actually have your actual application running with all the exact links to all the different parts of your application, to your subcontractors, or to whatever makes sense. And you don't rely on mock tests or on just a subset of your application. You rely on what your application is actually looks like. And you see that all the other environment, your network, your infrastructure, all the data you are gathering from those environments are coming from production. Do you imagine analyzing your operating system in your test environment and rely on that to protect your production environment? That makes no sense. So you will actually check what is actually running in production, and based on that, make a decision. But how can we do that? Well, we will just put the light in your application. We will deploy some sensor inside of your city, everywhere, on all the assets, on all the door, on all the locks. And with all of those sensors, we will create an AppSec graph. An AppSec graph is like the twin of your application, digital twin of your application. Everything that is happening inside of your application will be reported to the AppSec graph. And then imagine everything that you could do with this AppSec graph. You will have all the information that you need, all the libraries connection, all the connection with sub-application, everything that is important will be part of this graph. And then you just have to request a graph. That's all you have to do. Let me give you a bit of example on how that works. And by the way, this technology is called ADR. Yes, we will add another DR inside of your vocabulary, application detection and response, because it's working exactly the same way it's working on all the rest of your environment. So let's go maybe a bit more into the technical stuff. I will give you an example of an untrusted deserialization. Untrusted deserialization, for those who don't know it, it's specific types of attack that could happen in some languages. Basically, it's a way to transfer an object from an application to another application. So you export your object as binary format and you upload it to another application. But when it's in the binary format, by definition, you don't know what is inside. So if you try to scan it with a WASP, for example, you won't see anything. If you scan your application with a SAST, you will see that it's doing some deserialization, but it's not an issue by itself. The issue is what is inside of the object you are loading. And here, the AppSec graph can give you an actual value. Why? Because we will inject a sensor inside of the deserialization library, which means we will actually see what is being deserialized. And then based on that, we can report that to the graph saying there is a specific library being deserialized at that moment that is absolutely not doing something wrong inside of the application, or in this case, it's actually killing the application. So we have to take a decision. And you have the ability then to block these attacks directly, report it to the SOC team and provide them all the information that they need from the graph, telling them that this object was doing this, but this application, by the way, is communicating with this very critical database. But that's just one thing we can do with the graph. But we can also help the developers bring the graph. By requesting some information from the graph, we can also detect that there is misusage of a specific data. If we take the example of a SQL injection is very simple to explain. It's data coming from the user going to the database without sanitization. Well, let's just request that to the graph. And the graph will just give us the information from the production environment of all the requests that are coming from the user going to the database without sanitization. That's maybe not an attack, but that's a vulnerability for sure. And again, we will provide them all the information to the developers first to understand what is the issue, what they need to do. But also, we will be able to give them the vision of what happened in the production environment, saying that this actual vulnerability is actively exploited. Because we have seen some requests that definitely don't look legitimate touching this specific part of your application. And we can even tell you where that comes from. That's just a few examples of what we can do with a graph. And it's still dating and we will continue. But what is really important is that we have the ability to create this graph with a production instrumentation. And that what you need to remember is the ability that ADR can provide with this vision of the production environment.
Sure, thanks, Aurelien. So what we're doing with this technology, ADR, this is still very much early adopter technology. So we're still figuring a lot out, but it's out there and we're running a lot of tests. And this is data. We now publish a monthly blog on this. And what we've done, we've looked at all our customer data and we're analyzing it and we're thinking about it. And what we're seeing, and these are the statistics, that 426 million requests to dangerous functions, that is just simply an insane number. It's incomprehensible. And it actually means nothing. You're into the tyranny of large numbers at this point. Where it gets interesting is when we started looking at the 365,000, just slightly more curious security incidents. But again, if you're a developer, a SOC engineer, an AppSec engineer, good luck, because that's in a month. You just can't actually analyze that. It gets more and more interesting when you see the 4,000 probes. So then you know you're actually being targeted. So you're now into the world of threats and really begin to hone down how applications in production are being targeted. Then you see the 45 scripted, very advanced attacks. And on this particular month, this is from December of last year, it was deserialization. And these are the types of attacks which are going to bypass every form of defense you have at the moment, because our customers, like yourselves, are spending hundreds of millions of dollars on active defenses, but these attacks, these, crikey, these are some of the most sophisticated attacks in the world are getting through. And we saw 45 of them. That then turned into 5 particular incidents, which we could then block and then send that back to the development teams. We actually published some CVEs on it to actually then be fixed. And this is what we mean about context. On the left-hand side, that's just all noise. But could you imagine changing everything, flipping everything on its head? You now go back to the development teams and go, do you know that scan we gave you last month with the 3,000 vulnerabilities? Let's just put that to one side because I need you to fix these 5 pieces of code. And I can tell you why they need to be fixed, because we can actually show you how we're being attacked and we're only blocking them temporarily. So fix that code and do the fix permanently. And that's how we flip this game on its head. We stop the noise and get straight to the action. And suddenly you're now you're now into the whole DevOps cycle. No unplanned work, fast feedback loops, and more importantly, that trust which was destroyed back in 2005 with the big static analyzers between developers and AppSec, they're now going to start trusting you because the data you're giving them is that highly accurate, highly reliable, and it is crystal clear. There is no debate, you're under attack, do something about it. And that's how we're looking at ADR, it's flipping everything onto its head.
So, no, probably every one of you will say that, well, my organization will never let me do some tests in production. But that's not coming from us. That's from one of our customer. Remember that your customer are actually testing in production every day. That's where you have all the actual data. And that's where we need you. We need you to actually defend this vision of we need to actually detect the vulnerability and the attack in production, because that's where the actual data are. And actually today, it's more risky not to do that than actually putting Contrast or any other ADR product. We are not here to pitch Contrast, and there is plenty of other ADR competitor in the market. Try them. I won't tell you to take Contrast, but take ADR technology and look what ADR can actually do, because that will really solve lots of your issues.
And just really then one very, very sort of final thought on all this, it's going right back to the beginning. Where we are today is in a quagmire. We're not winning that particular battle. We do know that vulnerabilities are increasing, the fix rates are going down further and further, and we simply have to change. I was reading, actually on the train coming down, one of the great books on project management in IT. It's called The Mythical Man Month, and it was published in the 90s, and I think, and in that, and this is what you also have to bear in mind, this is early adopter technology, and in the Mythical Man Month, one of the key attributes is there is no silver bullet. ADR is not going to be the bullet which solves the application security problem. You still need fantastic architecture, secure architecture. What Gary McGraw was writing about in 1996 absolutely applies. In fact, we should probably get back to doing more of that, more threat modeling, more education, but we need to shift our emphasis away from potential vulnerabilities into those where you're being attacked, deal with everything right now, not in a theoretical construct. So those are the final thoughts. And Sam is looking at me very worried with a microphone. So, okay. Oh.